Okay, so I'm going to tell you how we can use markers of people's ability to make social inferences that we acquire in the lab to predict real-world differences in people's social functioning. And so just to set up the stage a little bit, I think we've all heard the statement that we as humans are a social species. I mean, it's a platitude, right? So no man is an island, and so forth and so forth. But we also know for a fact that people differ dramatically with regard to the number of social connections, the number of social relationships that they can build and maintain. And so some people are very successful in creating these social networks and in navigating these social environments, while other people clearly struggle to do so. And so one of the key hypotheses that we addressed in our study was the question whether the ability to infer other people's mental states, to mentalize, is related to these observed differences in people's social functioning in the real world, as measured, for instance, in the size of social networks. The way that we assess people's ability to infer others' mental states in a lab was by using the following task. So this is a very short, established task, the so-called levels of inference task, that was originally developed by Bob Spunt, who's totally awesome. And so in a nutshell, what we asked people to do in this task is we show them a series of images that either show facial expressions or intentional hand actions, and we asked them to make very quick judgments, so yes, no judgments. And these judgments either require people to engage in social inferences or to perform more shallow inferences related to action representations or factual inferences. And what's nice about this task is, as I already mentioned, it's very short, so it's 10 minutes and then you are done with it. And the advantage of the task is that it very reliably activates a network of brain regions that are widely believed to be the so-called mentalizing network. And so in this particular example, I show you results from a decoding analysis, but you can also do it univariately. And the nice thing is we can identify this particular network of brain regions also on a single subject level. And so what you see on the slide are brain regions that reliably decode whether people are currently engaged in social inferences or these kind of factual inferences. The key question that we addressed in the study, based on the hypothesis that I already mentioned, is the question whether we can use the brain responses obtained during social inferences, using this level of inference task, to predict variance in people's social functioning as captured in people's social network size. And the way that we measure social network size in this particular study is by using the social network index. Specifically, the way we realize the prediction is by using a very straightforward cross-subject decoding approach, a leave one subject out decoding approach. And so, in a nutshell, what that means is for each of these regions of interest that we reliably identify in the level of inference task, we extract these kind of multi-voxel response patterns for each of the RRIs, and importantly, we do that for each individual subject. And what we then do is train a support vector regression model to associate the subject-specific activation patterns with the social network size that we measure for that particular subject. And we train the model on the majority of our subjects, and then we test the model and ask if the model can predict other people's social network size simply based on their neural response patterns obtained during social inferences. And I mean, I wouldn't be here if it wouldn't work, so surprise, surprise. So what we can show is that this kind of decoding approach allows us to very reliably predict people's social network size out of sample. And what you see on the slide is the results for two independent samples of healthy individuals, a discovery sample and a replication sample. And what the scatter plot shows you is the correspondence of the real social network size index and the predicted social network size index. So just in case you wonder, so the scatter plot shows you the results, or on the scale you see the z-scored values of the social network size. It also works when you take the raw scores that you see in the histograms. Importantly, what we can also show is that we can extend this particular approach and show that we can also predict social network sizes in a sample of high-functioning individuals with autism. So people that often struggle with these kind of social interactions and building and maintaining these kind of social networks. And I think that's a really nice feature of the paper that we are currently preparing. And so one of the things that we were wondering is if this kind of significant prediction of social network size is specific to that particular index of social functioning. So can we only predict social network size, or can we also predict other indices? And again, I wouldn't have put it on the slide if I wouldn't have something interesting to say. And so one of the things that we were very excited to show is that we can use a similar decoding approach, same kind of brain responses to implement our decoding approach to predict variance in autistic traits in the general populations in our two samples of healthy individuals. And so the way we measured variance in autistic traits is using Baron-Cohen's autism quotient. And one of the things that I want to specifically point out is that these kind of AQ scores were not correlated with social network size. So it's not just one of the same kind of analysis, and I'm piggybacking on shared variance, but it's really another measure of people's sociability, so to speak. And so given that we could predict autistic traits in the general population, we then went back to the sample of the high-functioning individuals with autism. And what we can also show is that we can use this kind of decoding approaches to predict variance in the symptom severity in the social affective domain as captured in the ADOS-SA scores. And again, those scores were not correlated with variance in people's social network size. Okay. That's pretty much it. So let me just summarize the main findings. So there are two things that I would like you to take away from the talk. So the first thing is obviously just the first set of findings. So we can actually use these kind of multi-voxel brain responses obtained during social inferences to reliably predict variance in people's social functioning as measured in the social network size. And importantly, we could show that for 3 independent samples, which in my opinion speaks for the robustness of the effect. And I also want to point out again that it's not only working for healthy populations, but also for individuals with autism, which speaks in favor of the translational application of that particular approach. And just to bring it back to the main hypothesis that I introduced at the beginning, so we believe that this finding really speaks in favor of the hypothesis that social inferences and variance in that ability to do so is actually linked to variance in real-world social functioning as captured in social network size. And we believe that the LOI task gives us a reliable biomarker of variance in people's ability to engage in social inferences. The second thing that I would like you to take away is, again, it's not only predictive of social network size, but the approach allows us to predict variance in a number of indicators of people's social functioning. So I talked about a couple of them. And so the way we interpret these findings is that that these kind of neuromarkers of our ability to mentalize, as captured in the level of inference task, might actually capture a latent variable that drives variance in a number of indicators of people's social functioning. And so my time is up, but I want to take a second just to acknowledge my awesome collaborators, so specifically my collaborators at Caltech and the members of my newly established lab at Queen's University. And very self-serving, I'm recruiting, so if there's anyone interested in the work of our lab, please come and see me. And thank you.